NENOMATICA, where mathematics meets YouTube excellence. Welcome to our lesson on first-degree linear expressions. Today, we'll explore what linear equations are, how to solve them, and their various applications in mathematics. Let's begin by looking at the chapters we'll cover in our linear expressions journey. First, we'll explore first-degree linear equations in one variable. Then, we'll have a detailed discussion of these equations. Next, we'll learn about solving first-degree fractional equations. After that, we'll move on to solving linear equations in more than one variable. We'll also cover problem-solving using first-degree equations. Then, we'll analyze the signs of linear expressions. We'll explore linear inequalities, followed by a discussion of these inequalities. We'll then cover first-degree fractional inequalities. Next, we'll study parametric linear inequalities. We'll also learn about systems of linear inequalities in one variable. Then, we'll explore fractional and compound linear inequalities. Afterward, we'll study systems of two equations in two unknowns. Finally, we'll examine the types of systems of linear equations. Welcome to this math tutorial. Today, we're going to solve a first-degree linear equation step by step, following a clear algorithm. Let's start with an introduction to equations. Consider the following equation: 2x minus 3 equals x minus 1. An equation is a mathematical statement where the expressions on both sides are equal. The goal of solving an equation is to find the value of the variable that makes both sides equal. Let's check if x equals 2 is a solution to our equation. If we substitute x equals 2 into the equation, we get 2 times 2 minus 3 equals 2 minus 1. On the left side, 2 times 2 is 4, and 4 minus 3 is 1. On the right side, 2 minus 1 is 1. Since both sides equal 1, we can confirm that x equals 2 is indeed a solution to our equation. This means that when x equals 2, both sides of the equation are equal. Now, let's solve this equation systematically, following our algorithm. We start with our original equation, 2x minus 3 equals x minus 1. Our first step is to move all terms with the variable to one side of the equation. Let's move all terms with x to the left side. We subtract x from both sides of the equation. This gives us 2x minus 3 equals negative 1. Simplifying the left side, we get x minus 3 equals negative 1. The next step is to move all constant terms to the right side of the equation. We add 3 to both sides of the equation. This gives us x minus 3 plus 3 equals negative 1 plus 3. Simplifying, we get x equals 2. Therefore, the solution to our equation, 2x minus 3 equals x minus 1, is x equals 2. Let's verify our solution by substituting x equals 2 back into the original equation. On the left side, we have 2 times 2 minus 3, which equals 4 minus 3, which equals 1. On the right side, we have 2 minus 1, which equals 1. Since both sides equal 1, we confirm that x equals 2 is the correct solution. Let's summarize what we've learned about solving first-degree linear equations. First, we move all terms with the variable to one side of the equation. Then, we move all constant terms to the other side. Finally, we solve for the variable and verify our solution. This systematic approach works for any first-degree linear equation. Today, we'll be working through examples where we find the root of each equation by trial and verification. The trial and verification method involves guessing a potential solution, substituting it into the equation, and then checking if the equation holds true. Let's begin with our first equation. Find the root of the equation, 2x minus 4 equals 0. Let's guess that x equals 2 is the root. To verify this, we'll substitute x equals 2 into the original equation. We substitute x equals 2 into the equation, 2x minus 4 equals 0. This gives us 2 times 2 minus 4 equals 0. Simplifying, we get 4 minus 4 equals 0, which is 0 equals 0. Since both sides are equal, our guess x equals 2 is correct. Therefore, x equals 2 is the root of the equation 2x minus 4 equals 0. Now, let's move on to our second example. Find the root of the equation. Negative 3y plus 4 equals negative 1. Let's guess that y equals 5 over 3 is the root. To verify this, we'll substitute y equals 5 over 3 into the original equation. We substitute y equals 5 over 3 into the equation negative 3, y plus 4 equals negative 1. This gives us negative 3 times 5 over 3 plus 4 equals negative 1. Simplifying, we get negative 5 plus 4 equals negative 1, which is negative 1 equals negative 1. Since both sides are equal, our guess y equals 5 over 3 is correct. Therefore, y equals 5 over 3 is the root of the equation negative 3 y plus 4 equals negative 1. Finally, let's examine our third example. Find the root of the equation, a minus 3 over 4 equals 2. Let's guess that a equals 11 is the root. To verify this, we'll substitute a equals 11 into the original equation. We substitute a equals 11 into the equation, a minus 3 over 4 equals 2. This gives us 11 minus 3 over 4 equals 2. Simplifying, we get 8 over 4 equals 2, which is 2 equals 2. Since both sides are equal, our guess at equals 11 is correct. Therefore, a equals 11 is the root of the equation a minus 3 over 4 equals 2. Today, we're going to learn how to solve first-degree linear equations with one unknown variable. The general form of any first-degree equation can be written as ax plus b equals 0, where is the coefficient of x is the variable we need to solve for, and b is the constant term. Note that it cannot be 0, because then it wouldn't be a first-degree equation. Now, let's look at how to solve an equation of the form ax plus b equals 0. We'll follow a systematic algorithm that always works for these types of equations. Let's go through the steps of the algorithm. Step 1. We start with our equation in the general form. Here we have ax plus b equals 0. Step 2. Move all terms without x to the right side of the equation. In our case, we move b to the right side, which gives us ax equals negative b. Notice that when we move a term from one side to the other, we change its sign. Step 3. Divide both sides of the equation by the coefficient of x, which is a, to isolate x. So we have a divided by a times x equals negative b divided by a. Since a divided by a equals 1, we get x equals negative b divided by a. Step 4. The final step is to simplify our answer to get the value of x. Our answer is x equals negative b over a. We can also write this as x equals negative b divided by a, or x equals negative b over a. Now, let's look at an example to see how this algorithm works in practice. Let's solve the equation 3x plus 6 equals 0. Let's identify the coefficients in our equation. We have it equals 3 and b equals 6. Now, let's follow our algorithm. Step 1. We start with our equation 3x plus 6 equals 0. Step 2. We move the constant term to the right side, which gives us 3x equals negative 6. Step 3. We divide both sides by the coefficient of x, which is 3. This gives us x equals negative 6 divided by 3. Step 4. We simplify our answer. Negative 6 divided by 3 equals negative 2. Therefore, x equals negative 2 is our final answer. Let's verify our answer by substituting it back into the original equation. We have 3 times x plus 6 equals 0. Substituting x equals negative 2, we get 3 times negative 2 plus 6 equals 0. This simplifies to negative 6 plus 6 equals 0. And finally, we get 0 equals 0, which is true. This confirms that x equals negative 2 is the correct solution. Our first example is 2x minus 4 equals 0. Let's solve this step by step. First, we need to isolate the variable term. We'll add 4 to both sides of the equation. Now, to find the value of x, we need to divide both sides by 2. Let's move on to our second example, negative 3x plus 5 equals 0. Again, we'll solve this step by step. First, we need to isolate the variable term by subtracting 5 from both sides of the equation. Now, to find the value of x, we need to divide both sides by negative 3. Let's summarize what we've learned when solving first-degree linear equations. First, isolate the variable term by adding or subtracting constants from both sides. Then, isolate the variable by dividing both sides by its coefficient. Following these steps, we found that for the equation 2x minus 4 equals 0, x equals 2. And for the equation negative 3x plus 5 equals 0, x equals 5/3. Thank you for what equals 5/3. Our first step, we'll divide both sides of the equation by 3. This will help us isolate the expression with the variable x. For our second step, we'll keep the term with the variable x on the left side and move the constant to the right side. To do this, we add 7 to both sides. For the final step, we need to isolate x. We'll divide both sides by the coefficient of x, which is 2. Let's solve our second example. For this equation, our first step is to isolate the term with the variable y. We'll subtract 16 from both sides. Now, we'll divide both sides by -4 to isolate y. Welcome to this math tutorial. Today we're going to learn how to solve linear equations step by step. We need to solve the equation 100 equals 50 minus 4d. To solve this equation, we need to isolate the variable d. Let's start by adding 4d to both sides of the equation. This gives us 100 plus 4d equals 50. Now, let's simplify the right side by subtracting 100 from 50. This gives us 4d equals -50. To isolate d, we'll divide both sides of the equation by 4. On the left side, we have 4 divided by 4 times d, which simplifies to d. On the right side, we have -50 divided by 4. Finally, we simplify to get our answer. The value of d is -12.5. Let's solve another example. We need to solve the equation 7 minus 2e equals 19 minus 4e. For this equation, we need to get all terms with the variable e on one side. Let's move the term -4e to the left side of the equation by adding 4e to both sides. This gives us 7 minus 2e plus 4e equals 19. Now, let's combine like terms on both sides of the equation. On the left side, -2e plus 4e equals 2e. On the right side, 19 minus 7 equals 12. To isolate e, we'll divide both sides of the equation by 2. On the left side, we have 2 divided by 2 times e, which simplifies to e. On the right side, we have 12 divided by 2, which equals 6. Finally, we simplify to get our answer. The value of e is 6. Let's summarize what we've learned about solving linear equations. First, we need to isolate the variable term by moving all other terms to the opposite side of the equation. We can do this by using the addition or subtraction property of equality. Then, we combine like terms on both sides of the equation. Finally, we isolate the variable by dividing both sides by the coefficient of the variable. Remember to check your solution by substituting it back into the original equation. These steps will help you solve any linear equation with one variable. Thinking Face Quick Challenge. Try solving this equation on your own. 3x plus 5 equals 17. Pause the video and solve it. Pause button, ready for the answer? The solution is x equals 4. Let's start with our example. We need to solve the equation, a minus 3 all over 4 equals 2. To solve this equation, we'll follow a systematic approach. First, let's rewrite the equation by expressing the fraction with its numerator and denominator. We have 1/4 times a minus 3 equals 2. We're multiplying the fraction a minus 3 over 4 times it over a, which equals 1/4 times the quantity a minus 3. Next, let's expand the expression on the left side of the equation. We have 1/4 times a minus 1/4 times 3. This equals 1/4 a minus 3/4 equals 2. Now, let's move the constant term to the right side. We add 3/4 to both sides of the equation. So, we get 1/4 equals 2 plus 3/4. Let's combine the terms on the right side. 2 plus 3/4 equals 8/4 plus 3/4, which is 11/4. Now, we'll multiply both sides of the equation plus 3/4, which is 11/4. Now, we'll multiply both sides of the equation by 4 over 1. On the left side, we have 4 over 1 times 1/4 times a. On the right side, we have 4 over 1 times 11/4. Let's simplify both sides of the equation. On the left side, 4 over 1 times 1/4 simplifies to 1, giving us just a. On the right side, 4 over 1 times 11/4 gives us 11. Therefore, the solution to our equation is a equals 11. Let's verify this by substituting back into the original equation. A minus 3 all over 4 equals 2. 11 minus 3 all over 4 equals 8 over 4, which equals 2. So our answer is correct. Now, let's look at an alternative method to solve the same equation. Again, we start with a minus 3 all over 4 equals 2. First, let's express the fraction with its numerator and denominator. We have an alternative method to solve the same equation. Again, we start with a minus 3 all over 4 equals 2. First, let's express the fraction with its numerator and denominator. We have 1/4 times the quantity a minus 3 equals 2. Now, let's multiply both sides by 4. On the left side, we have 4 times 1/4 times the quantity a minus 3. On the right side, we have 4 times 2, which is 8. Let's simplify the left side. 4 times 1/4 simplifies to 1, giving us a minus 3 equals 8. Now let's add 3 to both sides. A minus 3 plus 3 equals 8 plus 3. So a equals 11. Once again, we get the same answer. A equals 11. Both methods are valid approaches to solving this first-degree equation, and they both lead to the same correct solution. Let's summarize what we've learned about solving first-degree equations. First, identify the form of the equation, and methods are valid approaches to solving this first-degree equation, and they both lead to the same correct solution. We'll solve the equation 2.5 plus 0.3x equals negative 1.1. The first step is to isolate the term with x on one side. Let's move the constant 2.5 to the right side of the equation. To do this, we subtract 2.5 from both sides. This gives us 0.3x equals negative 1.1 minus 2.5. Next, let's simplify the right side by performing the subtraction. Negative 1.1 minus 2.5 equals negative 3.6. So, our equation becomes 0.3x equals negative 3.6. Now, to isolate x, we need to divide both sides by the coefficient of x, which is 0.3. So, we have x equals negative 3.6 divided by 0.3. Notice that we're dividing both the numerator and denominator by the same number, which is 0.3. Finally, when we divide negative 3.6 by 0.3, we get negative 12. So, the solution to our equation is x equals negative 12. Now, let's move on to our second example. We'll solve the equation 4 times the quantity 5 minus 2, y equals 5.6y. First, let's distribute the coefficient 4 to the terms inside the parentheses. 4 times 5 is 20, and 4 times negative 2y is negative 8y. So, the left side becomes 20 minus 8y. Next, let's move all the terms with y to the right side. We add 8y to both sides of the equation. This gives us 20 equals 5.6y plus 8y. Now, let's combine like terms on the right side. 5.6y plus 8y equals 13.6y. So, our equation becomes 20 equals 13.6y. Finally, to solve for y, we divide both sides by 13.6. So, 20 divided by 13.6 equals y. This gives us y equals 20 over 13.6, which simplifies to approximately 1.47 or 20 over 13.6. Let's summarize what we've learned about solving linear equations. First, we distribute any coefficients to terms in parentheses. Then, we move all variable terms to one side and all constant terms to the other side. Next, we combine like terms. Finally, we divide both sides by the coefficient of the variable to find our answer. These steps will help you solve any linear equation. We have the equation 5x minus 2 equals 3x plus 4. Our first step is to move all terms with the variable x to the left side of the equation and all constant terms to the right side. To do this, we'll subtract 3x from both sides of the equation. This gives us 5x minus 3x equals 4 plus 2. Next, we'll combine like terms on each side of the equation. On the left side, 5x minus 3x equals 2x. On the right side, for plus 2 equals 6. So our equation becomes 2x equals 6. Finally, we need to isolate the variable x by dividing both sides by the coefficient of x. We divide both sides by 2 to get x equals 6 divided by 2, which simplifies to x equals 3. Now, let's move on to a more complex example. We have the equation 3 times the quantity x plus 5 equals 2 times the quantity negative 6 minus x minus 2x. The first step is to expand all the brackets in our equation. On the left side, 3 times the quantity x plus 5 becomes 3x plus 15. On the right side, 2 times the quantity negative 6 minus x becomes negative 12 minus 2x. Then we subtract 2x, giving us negative 12 minus 2x, which is negative 12 minus 4x. Next, we'll move all terms with the variable x to the left side of the equation. We'll add 4x to both sides. This gives us 3x plus 4x plus 15 equals negative 12. Now, we'll combine like terms on the left side of the equation. 3x plus 4x equals 7x. So our equation becomes 7x plus 15 equals negative 12. Next, we'll move all constant terms to the right side of the equation. We'll subtract 15 from both sides. This gives us 7x equals negative 12 minus 15. We'll combine the constant terms on the right side. Negative 12 minus 15 equals negative 27. So our equation becomes 7x equals negative 27. Finally, we need to isolate the variable x by dividing both sides by the coefficient of x. We divide both sides by 7 to get x equals negative 27 divided by 7, which simplifies to x equals negative 27 over 7, or negative 3 6/7. Let's summarize the key steps for solving linear equations. First, expand any brackets in the equation. Second, move all terms with variables to one side of the equation. Third, move all constant terms to the other side of the equation. Fourth, combine like terms on each side. Finally, isolate the variable by dividing both sides by the coefficient of the variable. Following these steps systematically will help you solve any linear equation. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.